the rules of differentiation provide us a shortcut to that will substitute eventually the limit definition of the derivative, which sometimes can be a little bit more difficult. So let's take stock of what we know so far. Okay, let's look at the first one. Let's say that f of x equals some constant c, okay, or y equals c. So c is a constant. Well, we are looking at the at y equals c, which I put in parentheses. This is a horizontal line. As such, the slope of the horizontal line is 0. And we know that the derivative at a point is the slope of the tangent. And the derivative as a function is the slope of a tangent at any given point along the curve of f of x. So it stands to reason that f prime of x, so we'll use Leibniz notation, d dx of c, remember those notation? Or c prime, like so, it stands to reason it's equal to 0, okay, the slope of a horizontal line okay, but if we do it by the definition, because this is what we know, in general, f of x is defined as the limit as h approaches 0 of f of x plus h minus f of x over h. Okay. This is something you need to frame, hang on the wall. And so in this case, so f of x equals c, and because x is not in the function, then f of x plus h is also equal to c. And therefore, d dx of c, or c prime, equal the limit as h approaches 0 of c minus c divided by h. So it's simply 0. And we have one rule, okay, the constant rule, d dx of c equal to 0. All right, so that's one rule. Let's call it constant rule. Next. Something that pretty much what I'm going to do now, the next three, or the next two examples, check it, the next three, is something we already seen before, so it just I'm putting it together. So number 2, f of x now equals x. Again, this is y, the line y equal x. Recall, so what is the slope of the line? Well, the slope of y equal x is 1. So therefore, we can stand to the reason that d dx of x or x prime equals 1. Okay, that's common sense, but again, let's do by the definition. It's easy to see that this is true. D dx of x or x prime, like so, is the limit is h approaches 0 of x the function is x, so f of x plus h is simply x plus h. And you can see it's the limit, x minus x is 0. The limit as x goes to 0 of h over h, or it's 1. So that's pretty much covers it. So now we have this rule, d dx of x equals 1. Let's not give it a name at this point. Next, I'll call it 3a because it's a part of a bigger picture. F of x equal the parabola x squared, right? So with this, in this case, we'll go right to the definition. By definition, d dx of x squared, or if you want to use the prime notation, x squared prime equals the limit h goes to 0. Instead of x squared, we have x plus h squared minus x squared divided by h. At this point, I'll start writing, instead of dividing by h, I'm going to multiply by 1 over h, and then I'll expand. X plus h squared is x squared plus 2xh plus h squared minus x squared, and of course x squared and x will cancel out. So I need to multiply 2xh plus h squared by 1 over h, and we end up having the limit of a 2x plus h, and after substitution we have 2x. After substitution, so here's another rule, d dx of x squared equals 2x. Again, we leave it unnamed. And let's do 3b. What the heck, let's call it 3, and this one will be 4. Okay, f of x equals x cubed. Again, by definition. Then we can come up with the rule after that. D dx of x cubed equal the limit as h goes to 0 of x plus h cubed minus h cubed minus x cubed divided by h. And if we expand x plus h cubed, the expansion will have the coefficient 1, 3, 3, 1. Did I show you Pascal triangle? I'm sorry? Yeah. And the way it works is, so the coefficient will be 1, 3, 3, 1. Okay? X, we start with x cubed, so it will be 1 times x cubed, h to the power of 0, which is 1, plus 3 times x squared, h to the power of 1, plus 3, x to the power of 1 times h squared, plus 1 times x to the power of 0, h cubed. Okay, so the coefficient 1, 3, 3, 1. And then we subtract the x cubed, and we close the bracket. Of course, x cubed and x cubed cancel each other, and we end up having the limit as h approaches 0 of 3x squared h plus 3x h squared plus 1 over h right here front plus h cubed. And as you multiply, everything by 1 over h, you clear the parentheses, you end up having 3x squared plus 3xh plus h squared. Okay? Substitute h with a 0, and you end up having 3x squared. So here's the rule. d dx of x cubed is 3x squared. Oops. So now we can make an observation. Actually, I'll pause right